All right, we have 4.1 matrix. When we're talking about more than one of them, matrices is how we pronounce it for plural. First of all, a matrix is a rectangular arrangement of numbers in rows and columns. The rows go across and the columns go up and down. When you're asked to describe a matrix, we describe it by using its dimensions. The dimensions are rows by columns, and we do use this little X for the word by. Much like when you're doing measurements, a 2x4 or a room is 5 feet by 10 feet. We use that little X to mean by. It does not mean multiplication. It's rows by columns. So here we have a couple of examples. If you're given the matrix A, B, C, D, E, F, and you're asked for the dimensions of it, you would say it's a 2x3 because there's 2 rows go across, and 3 columns that go down. So it's a 2x3. Over here, this matrix is inside of it, the elements are 2 and 1. We would say its dimensions are a 1x2 because there's 1 row going across, and then there's 2 columns. So it's a 1x2. We're going to be able to do quite a bit of things with matrices. The first thing we're going to do is we're going to add and subtract matrices. When we add and subtract matrices, the very first thing that must be done is that the dimensions must be exactly the same. If they are not exactly the same dimensions, you cannot add and you cannot subtract. So you have to look for, are they the same dimensions? Once we decide that they are the same dimensions, well then we just combine the same positions. So here I have 3 examples. First example has 8, 3, -1, 4, -2, 7. And we're going to add that to the matrix 4, 0, -1, -1, 2, and 5. So the first thing you have to do is you have to decide, are they the same dimensions? And in this case, the first one has 2 rows going across and 3 columns going down. And the same thing goes for the second one. It is a 2x3 as well. Because they are 2x3, they have the exact same dimension. We then get to add the same positions together to make one matrix. So we're going to add the same positions to make one matrix. So we add the 8 and the 4. They're in the same position. We add them together. 3 and 0. -1, -1. 4, -1. -2, 2, 7, and 5. So we add the same positions. Therefore, we get the same size or same dimension of a matrix, a 2x3. All right, try it again. Here we're going to have the matrix 4, 1, 3. And we're subtracting -3, 2, and -1. First thing you have to do is you have to make sure that they are the same dimensions. And in this case, there are 3 rows and only 1 column. So 3 by 1, 3 by 1, we can subtract them. They are the same dimensions. When we combine them, in this case we're subtracting because that's what the sign says to do. Subtract the same positions. So we're going to take 4 and we're going to subtract the -3. 1 subtract 2. 3 subtract a -1. Keep in mind our signs. Therefore we get the matrix 7. 1 minus 2 is -1. 3 minus a -1 is +4. Alright, our last example over here has the matrix 2, 0, -1, 4. And we're going to add it to the matrix of 1, 3. First thing we need to do is check the dimensions. We see this is 2 rows by 2 columns. This is 2 rows, but only by 1 column. Therefore, you cannot do it. They are not the same dimensions. You cannot add and you cannot subtract unless they're exactly the same. Alright, the next thing that we're going to do with our matrices is that we're going to do a multiplication by a scalar. A scalar is nothing more than a number that's in front of our matrix. Notice our matrix does use these brackets for its notation. It is not an absolute value because an absolute value does not have the little tops and bottoms to it. So a scalar is a number outside of the matrix. When we're multiplying by a scalar, all we're really doing is distributing. We're going to take 3 to the 4 and get 12. 3 to the 7, 3 to the -1, and 3 to the 2. Distribute. And that's how we use a scalar. The next thing we're going to do is we're going to solve. Well, solving just uses our order of operations, meaning we do grouping symbols, exponents, multiply, divide, and then add, subtract. For this particular problem, I have 4 on the outside parenthesis of these 2 matrices inside. Inside the parentheses, it wants me to add the 2 matrices in 8, 0, -1, 2y. The other matrix is 4 minus 2x, 1 and 6. So order of operations. So I'm going to do inside the parentheses by adding. When I add 8 and 4, 0, -2x, -1 and 1, and then 2y and 6. When I add those together, that's my result. Now, order of operations, say I'm going to multiply by this scalar. 4 times 12, 4 times -2x, 4 times 0, and then 4 times 2y plus 6, so that's a distributing. So that's where 8y plus 24 comes from. And then by definition, if things are equal, they have the same value. So 48 equals 48, -8x equals -48, 0 equals 0, and 8y plus 24 equals 8. Well, the first column here does nothing for me. There's no letters. It is true. 48 is 48 and 0 is 0. But the second one is where I have some solving. And I can divide by -8 on both sides. And get that my x value is 6. Subtract the 24 and divide by 8. And I get my y value is -2. So following simple order of operations, adding, scalar, set each piece equal to one another, and the ones that allow you to solve for them. So that's going to be 4.1.